We're going to begin talking about a different topic, but it has to do with combinations. So we've talked about permutations and how to count things with the fundamental counting principle. We've talked about combinations and how to count the number of ways you can do something with those. And then we're going to get into what is called binomial expansion. And binomial expansion just means you're trying to expand a binomial meaning two terms. So you're going to start with x plus y to some power. It doesn't have to be x and y. It can be anything like 2a plus 3b to the fifth power would be a binomial because it has two terms. It could be plus or minus. Either way, it works. And we're going to apply combinations to binomial expansion. Okay. And the first thing we're going to do, though, is show you sort of a quick way of doing binomial expansion using what is known as the Pascal's triangle. Okay, so I've written out Pascal's triangle right here for you. And essentially what Pascal's triangle does is it tells us the coefficients. Okay, so we're looking at the coefficients for each of these terms. So in other words, if you do x plus y to the 0, you get 1 as your answer. If you do x plus y to the 1, you get 1x and then 1y. So it's giving you the coefficients, the numbers in front of the x's and y's. If you do x plus y squared, it's 1x squared plus 2xy and then plus y squared with a 1. We don't have to write the 1, but you can see where those are coming from. Okay? If you're doing x plus y cubed, it's 1x cubed and then 3x squared y and then 3xy squared and finally 1y cubed. And again, you can see the coefficients are 1, 3, 3, and 1. The other thing that this is doing with binomial expansion, if you notice the pattern of your x's, the x's always start with the power that's on the binomial to begin with. So squared, squared, cubed, cubed. Okay? The y's always start with nothing. They start with 0. So the very first term never has a y in it. Okay, and then what happens is the x powers go down by 1 as you go along. So they went from here 3 to 2 to 1 to 0. Here they went from 2 to 1 to 0. Here they went from 1 to 0. Okay, and the y terms, the second term always starts with 0 and goes up by 1. So you have 0, 1, 2, 0, 1, 2, 3. So essentially what happens is the powers of both of the terms, the x and the y together, they always add up to the power that's on top of the binomial to start. So here they're always going to add up to 3. So there's 3 plus 0, 2 plus 1, 1 plus 2, and then 3 plus 0, or 0 plus 3. Okay, so the idea behind Pascal's triangle is it tells you the number that goes in front of each of the terms in your binomial expansion, and the pattern then is that each term, the first term starts with the biggest power and the second term starts with 0, and they just each change by 1 each time. So the first term goes down by 1 and the second term goes up by 1. All right. Now I'm going to show you another example. Just bear with me 1 second here. I'm just going to erase this. So there's x plus y cubed. We've done that, but let's imagine that I do what was up here. So it's 2a plus 3b to the fifth power. Okay? And I want to figure out what that is. So for our purposes, this right here is my first term. It's like my x. This is my second term. Okay, and then if it's the fifth power, I go up to Pascal's triangle, and this is the row I'm talking about. So the coefficients are 1, 5, 10, 10, 5, 1. All right? So we go 1 is the first coefficient, and then we start with the first term to the highest power. Then we do the next coefficient is 5. We do the first term to the fourth because it's coming down 1, and the second term now shows up because it was at 0, now it's at 1. Then we do the next term is 5, that's the coefficient. Sorry, no, it's not, it's 10. Look back up here, 1, 5, 10. And then it's 2a cubed and 3b squared. And then the next term is also 10, it's 2a squared and 3b cubed. Then we have 5 on the 2a, it's going down by 1 again, and 3b to the 4th. And finally, the last term is 1, and then it's 3b to the 5th. Okay? So that's how we would expand it using Pascal's triangle. And then what we do is we just have to actually work this out. So 2 to the 5th is 32. And you get 32a to the 5th. And then 2 to the 4th is 16. Then you have to multiply 16 by 3. So let's just write this out. We'll get 16a to the 4th, and then you have to multiply that by 3b. Okay, so you have to go 5 times 16, that's 50 plus 30, so it's 80. 80 times 3 is 240. So you're going to end up with 32a to the 5th plus 240, and then a to the 4th b. All right, and the next term would then be 10 times 8a cubed, and then times 9b squared. So you're going to end up there with 10 times 8 is 80. 80 times 9 is 720, and you're going to have a cubed b squared. Okay, and then we would continue on. We won't finish that just for the sake of time in the video, but that's the idea, that each time it would be worked out as 2 squared and 3 cubed next, and then 2 and 3 to the 4th next, and then finally 3 to the 5th. Okay, and you would just multiply those all together. So that's how you use Pascal's triangle. You just look at the power and go to that row. Okay, now you might be wondering, well, where did this come from, or how does this work? And essentially what Pascal's triangle does is it takes the next term from the previous two, you add them together. So it always starts with 1, but then you add these two terms to get this one. So that's 6, and then you add 10 and 5 to get 15, then you add 10 and 10 to get 20, then you add 10 and 5 to get 15, then you add 5 and 1 to get 6, and then finally you get 1. All right, so this would be the next row, which would be x plus y to the 6th power. So that is how you use Pascal's triangle to do binomial expansion. Okay, now the question is there a different method or a better method? Because the only way to use Pascal's triangle is to start with the top row and kind of work your way down, right? So if I asked you what's x plus y to the 20th power, you would have to write out the triangle until you got to the 20th power, and that's a lot, okay? So the better way to do that is with combinations, and this is where combinations come in. So I just want to show you something. When we do x plus y cubed, we know it's 1, 3, 3, 1 for Pascal's triangle. But what you'll recognize is that that is actually, those are the values for 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Okay? So you can use combinations to find any coefficient, any term coefficient, by using combinations, saying the n in the combination is the initial power. So again, if we just write out x plus y cubed, okay, this becomes our n down here. And then this is the power of the second term, or the first term. It really doesn't matter, because you'll notice that it's symmetrical, right? Pascal's triangle is. If we scroll back up to Pascal's triangle, you can see it repeats. It's 1, 3, and then 3, 1. It's 1, 4, 6, and then 4, 1, right? It's 1, 5, 10, 10, 5, 1. So it's symmetrical through the middle. So it doesn't matter whether you use the second term down here or you use the first term, because all it does if you use the first term is reverses the order. It's 3 choose 3, 3 choose 2, 3 choose 1, and 3 choose 0. But they happen to be the same, because if you choose none, then that's the same thing as choosing 3 of the other one, if that makes sense. So if I'm not choosing any y's, then I'm choosing 3 x's. It's sort of, you want to think about it that way. All right? So you can use Pascal's triangle to do binomial expansion, or you can use combinations. All right? And the general statement in terms of Pascal's triangle is that if you have x plus y to the n, the coefficients are n choose 0, n choose 1, n choose 2, all the way through to n choose n. Okay? So imagine I gave you p plus q to the 6th power, and I said find out what that is. The first way we could do it is to use Pascal's triangle. We just wrote out the 6th row of Pascal's triangle, so we know it's 1, 6, 15, 20, 15, 6, 1. All right, so we could do that. Or the other option is to use combinations. And to use combinations, we would go 6 choose 0, that's our first coefficient, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. And you can find those values on your calculator, or you can use the formula that we've talked about for combinations. Okay, so you can do that either way. You will get the coefficients, 1, 6, 15, 20, 15, 6, and 1. All right, either way. Either you use Pascal's triangle or you use combinations. They give you the same thing. But what's interesting, too, about this, just to notice, is that the first term, p, is starting with the highest power and going down by 1, right, each time. So it's p to the 6th, then 5, then 4, then 3, then 2, then 1, then none. And the q is starting at 0, so we don't write it, and then 1, 2, 3, 4, 5, and 6. Okay, so to do a Pascal's triangle or just binomial expansion using combinations, you just have to start with the coefficient, which is always 6. Sorry, not 6, it's n choose 0, then n choose 1 all the way down, depending what n is. N is the power that you start with. And then it's the first term to the highest power down, 1 each time until you get to 0. And it's the second term to the lowest power, which is 0, all the way up. Okay, that's how Pascal's triangle and combinations work, or the binomial theorem works. So this is the binomial theorem written out in mathematical notation. It's n choose 0, that's the coefficient, n choose 1, n choose 2, all the way up to n choose n. Then the first term gets the nth power to start. It gets all of the power, basically, and then you subtract 1 all the way down until you get to finally 1 and then 0. And the second one starts out at 0, goes up by 1, so it goes 0, 1, 2, all the way up until you get to n. So it has all of them at the end. That's the binomial theorem. That's the mathematical way of writing it. It looks a little more complicated, though, than it really is. Okay, so if we're going to do an example, this is on page 540, but it says 2a minus 3b to the 4th power. I want to know what that is. All right, so I start out by saying I need the coefficient is going to be 4 choose 0 to start, okay, because the power is 4 here, so it becomes my n, and I start at 0, and I just go up by 1, so it's n choose 0, then n choose 1, n choose 2, all the way up. Then the first term gets all of the power, so it's to the 4th. The second term isn't there, it's 0. Then we go 4 choose 1, that's my next coefficient. We go 2a to the 4th minus 1, right, we're going down by 1, so now it's 2a cubed. And the second term now goes from 0 to plus 1. You were adding 1 to that power. So now we have minus 3b. Okay, then we go 4 choose 2. That's the next coefficient. We take 1 away from 3 to get 2a squared, and we get minus 3b squared because it's going up by 1. Then we do 4 choose 3. 2a is now from 2 to 1, and minus 3b comes from 2 to 3. And finally, we have 4 choose 4 and minus 3b to the 4th power. Okay, and then it's just a matter of working out what that is. So 2 to the 4th is 16. Okay, and then 4 choose 0 is 1. Then 4 choose 1 is 4. 2 cubed is 8. A cubed, and then minus 3b stays there. Then we have 4 choose 2. Okay, so that's 6. And again, you can find that on your calculator using your combination button. And then 2a squared becomes 4a squared, and then minus 3 squared is 9b squared. Okay, and you do that for all of the terms. So the next one is 4, then 2a, and then 3 cubed is minus 27, or minus 3 cubed is minus 27, and then finally 3 to the 4th is 81, and you end up with your answer. So that is how you do binomial expansion with combinations. We'll do one more video where I'll show you a few other things, but that is the basic concept.